livestock all over Arizona. So with that, Retta, you enjoy.
Okay.
Interesting story.
Okay. Hello. Can everyone hear me? Whoops. Well, unfortunately today I'm not going to tell too many stories about what we did while herding, but I'll explain the research. So, as Eric introduced, my talk is on how effective is targeted grazing, and it's primarily on my thesis research, which was on targeted grazing. I think we've already explained the concept of targeted grazing today, but this study occurred in the Santa Rita Mountains of southeastern Arizona, and it was in part initiated by the Forest Service, who were concerned about fuel loading on Forest Service lands that was created by layman's love grass. And with that, I'll move on. Just to review some of the past literature on targeted grazing applications in terms of fire. Targeted grazing has been used in just a few studies that I could find. One notable one is on cheatgrass in the Great Basin of Nevada. And in this study, researchers used targeted grazing in combination with controlled burns to alter fire behavior. And then they ran controlled burns to see how the grazing affected the behavior of the fire. And they found that targeted grazing was an effective technique to reduce the severity of the burns, the rate of spread, and that also when areas were grazed before they were burned, it left islands of unburned vegetation within the plots. So in this study, our objectives were a little bit different. In the study I just mentioned, researchers used fences to target cattle grazing in specific areas, and we were looking to use herding and strategic supplement placement. So our study sort of had a behavioral component as well as a fuel impact component. We measured behavioral variables using GPS collars on the cattle to see how low stress animal handling and supplement placement changed their behavior, and then we measured a range of vegetation variables to see how that affected the layman's love grass in the area. This particular pasture is extremely rugged. It has some very steep elements, it's rocky, and there's lots of sharp vegetation. And so these methods were sort of developed to address common range challenges in the western United States, where we may have very large pasture and not a whole lot of infrastructure or funds to be able to change management paradigms or to install more fences or water sources. So we were really looking to see how herding and supplement might be able to change cattle distribution without expensive infrastructure development. So, to talk a little bit about the low moisture block supplement, this was a Crystallix supplement, and it's a protein supplement. It's been used in past range studies to affect distribution, and I think Mitch will talk a little bit more about this in a second, but we found that exposing cattle to the supplement beforehand was really critical in terms of them utilizing it when they were out on the range. And we put about 500 to 600 pounds of supplement in each site that we herded to. We also used low-stress animal handling, which is an animal handling technique that was sort of popularized and developed by the late Bud Williams. And it uses cattle behavioral principles, such as the flight zone, angle of pressure, and the use of release to direct cattle movement. So this is kind of a little visualization showing the vectors at which the yellow person would approach the cattle in this particular situation. And past studies have shown that low-stress animal handling in conjunction with strategic supplement placement has been effective at changing cattle distribution in large western pastures. Specifically, in past studies, it helps move cattle away from riparian zones and increased the amount of time they spent in upland sites. So to talk a little bit about our study area, as I said, it was in the Santa Rita Mountains, which is in southeastern Arizona. You can see here, right there with little stars. Whoops, star. And the vegetation types are oak and mesquite savanna and desert grassland, with the dominant vegetation being layman love grass, or Eragrostis laymanea, which is an introduced species from South Africa. The pasture was about 8,000 acres, but only about 3,000 were really usable by cattle because a lot of it is quite steep. And it's characterized by very warm summers and mild winters. So let's see here. I'm going to go through our study design. We had two treatments. We had target and control. Target meant that we herded to a site and that we placed supplement in the site. Control sites, we didn't herd to them and they had no supplement in the site. We used a Latin square design, which means we paired sites. And we did this to, well, it means many things, but one of the things it means is we compared sites so that we could block for two factors in this field study where there was a lot of variability. So we had 4 experimental units, and so we had this western pair of sites that were paired together and this eastern pair of sites. And we did this so that we would never herd to 2 sites that were right next to each other within the same year. I don't know if this picture shows it, but there's a big ridge right here. So these sites are a little more similar to each other, and these sites are more similar to each other, and we wanted to make sure that we weren't herding cows here and then the next month herding them there. So that explains why we did that. And then what we would do is, I'm going to run through some visualizations. Each of the little dots you're about to see represents a fix that was taken of where a cow was every 10 minutes for the 10 days before we began herding. So what we did in this study is we released cows into the pasture. They had free reign of the pasture for 10 days. There was no supplement, no herding, and they did whatever they want. Then we placed supplement in one of the sites, and we would herd the cows to the site. Then again, we didn't interfere with them. There was no supplement left in the pasture, and they roamed freely. And then again, we would herd them to a site. So that gives you an idea of how the study worked. We used telemetry data. We measured several dependent variables. We had telemetry data in the form of GPS collars on the cattle. We measured fecal loading in each study site, which gave us an idea of how much time cows spent in the study sites. And then we measured several vegetation variables, including utilization, stubble height, biomass, standing dead, and frequency and cover. And with utilization, stubble height, biomass, and standing dead, we measured those variables before cows entered the pasture in the fall and after the cows left the pasture when we were finished herding them. And the frequency and cover variables we measured before herding began each year of the study. So the data was analyzed, as I mentioned, in a Latin square and a 2-way repeat measures, ANOVA and a Latin square, with 2 factors that each had 2 levels. And I can explain more about this if others have questions afterwards. But to move on towards our results, as I explained before, each one of these dots you see here on the screen represents a point that was taken every 10 minutes for the 10 days prior to herding in 2010, the first year of the study. We had 4 collared cows each year. We had more collared cows than that, but some of the collars didn't work. So before we started herding, we found that cows spent 0% of their time within 100 meters of target sites, and that they spent 11% of their time within 100 meters of control areas. So you can see that over here, cows nearing that area. But there was no significant differences between use of control sites versus target sites when we weren't herding cows. The next thing we did was, well, the first site we herded to was study site, just arbitrarily labeled 1. That's over here. And so we placed supplement there, we herded the cows there, and I'm going to run through the next couple of slides that show every herding period just so you get an idea of the movement, and then explain a little bit about what those results mean. So this is cows roaming freely, cows herding to site 4, cows just going wherever they want, herding to site 2. You can see second year of the study we had a lot more winter rains, and so ephemeral springs developed. This is just cows going wherever they want. Whoops. All right, back on track. So this is our stubble height data, and we found a significant decrease in stubble height in target sites compared to control sites, looking at before grazing and after grazing. However, again, grazing did occur on the control sites because they weren't blocked off from cattle. Fecal pats, this is a measurement that we took using the methodology of Tate and all, if anyone is interested. And we found that fecal pats increased on target sites compared to controls, and that was a significant increase compared to pre-herding and post-herding and target and control. And then in terms of lasting impacts on the vegetation, we didn't find that there were significant changes in frequency and cover between year 1 and year 2. Easier to herd after they were introduced to a site, and they developed cattle trails to those sites, and once that happened, it was much easier to get them there. We found that herding in the afternoon was effective. As I mentioned before, when we herded in the afternoon, the GPS data showed that the cattle got there in the afternoon and they spent the whole night and then would leave in the morning for a drink. And then we also found that use of sites declined rapidly once the supplement was gone. So, in conclusion, did we meet our objectives? Was cattle distribution changed, and were fuel loads reduced? And we found that yes, targeted grazing did change cattle distribution, and it did reduce fuel loads. However, the utilization was less than you would expect given the stocking rate for those sites that we were targeting. And there's many explanations of why this is. One of them is that cattle had access to the whole pasture, and they also had access to all kinds of vegetation besides layman's lovegrass, which was the dominant vegetation in the sites. When applying targeted grazing, managers will want to think about their objectives and consider extending the length of the herding period if that's appropriate, or putting more supplement on the sites to increase the incentives for the cows to continue grazing there. So thank you, and I also want to thank all the people. This was very much, I guess it said that I made the presentation, which I did, but this was a collaborative study, and we couldn't have done it without the help of all the people who are here today, all the students from New Mexico State University, my advisor, and the Forest Service. Sean Lockwood, I believe, is here today, and Chuck Duncan, who recently retired. So these were extremely helpful partners, and it really wouldn't have been possible without them. So, thank you very much. Questions?